Okay guys, in this video we're going to be talking about acids and bases, and I'm going to show you guys what I like to call the horseshoe, and it's going to help you solve a lot of problems regarding acids and bases. Calculating pH and hydrogen concentration, I'll get into that when we get there. So to start off, I wanted to talk a little bit about the properties of acids, bases, and neutral substances, and so let's get right into that. So firstly, the main properties of acids are, is the pH. This is the one thing that is most indicative of whether a solution is acidic or basic or neutral. And so, talking about the pH of each of these, the pH of an acid is between 0 and 6.9. Or actually, it's anything that's less than 7 is an acid. And neutral substances, the pH is equal to 7, and for bases, the pH is equal to anything greater than 7. Anything greater than 7 is a base. Now, another property that people like to use is conductivity, and so both acids and bases will conduct. So they do conduct. So that's one point. Electricity. They conduct electricity. The same is true for bases. Another thing is the taste. Now, for bases, it's kind of varying. People say that bases are bitter, but I don't like to put anything in this category for bases because it's not very universal for all bases. So let's just stick to acids. Let's say that acids have a sour taste. Now, another one is an empirical property of acids and bases. It's the effect they have on litmus paper. So acids will change blue litmus to red. And the opposite is true for bases. They change red litmus to blue. And the way I like to remember it, it's not really a useful tip, but bases turned blue is what I use. Bases turn blue, and so you just can use that to remember the other one. And for neutral, that would be no change in litmus paper color. The color of the litmus paper in a neutral substance will not change. And another one, and this is a fairly important one, especially for calculations, is when they react with water, when acids react, they dissociate to form, to make hydrogen ions, or hydronium ions, which is H3O, and bases will dissociate to make hydroxide ions. Now, a property of acids and bases is that is the same for both, is that they both react with each other to try and form a neutral solution. Like, it's not always the case that it is a neutral pH that they produce, but that's where they're trying to go. And you'll learn more about that when we're talking about titrations later on in another video. So here, pH of acid is less than 7. pH of a base is greater than 7. Neutral pH is 7. Water is neutral. Pure water is neutral. And that's that, yeah. So the trick I wanted to show you for calculations, the thing I call the horseshoe, is a very useful. It's a very useful trick, and it has a lot of value, and you'll realize that when you start to do calculations of the sort. And I'll do a couple examples of this in another video, but I just wanted to introduce it here. And so, for the questions you'll be dealing with in this unit, you're going to be looking at things like how much the concentration of hydronium ions of an acid are, or if you're given the pH, you might be told to see how basic it is by saying what is the concentration of the hydroxide ions. And so this is a little horseshoe that you can do. So I would memorize this tip. I mean, I don't like to tell people to memorize things, but this is something you should memorize, because it's not on a formula sheet, it's not something there's an easy mnemonic for, it's not something you can really understand, it's just something you have to know. And so I say that you should memorize it for that reason, and that reason only. And when you're writing a test, I would put this on the test paper, and it'll really help you out. So in order to go, so what